Okay, so one of the main things when I'm looking through your proofs today is you're not communicating enough where your equations are coming from. You must reference the formulas when you're making your simplifications, and I'll do it in a few different ways. So in this first one, we need to say where this equation I'm about to write down comes from. So from the distance formula. From the distance formula, we get that PQ is equal to the square root of the cosine of B minus the cosine of A all squared plus the sine of B minus the sine of A, the sine of A all squared. Doesn't matter which you choose as your y1 and your y2. It could be the cosine of A minus the cosine of B. It'll be the same as long as you keep them in the same order. So then once we've done that, we can expand and simplify and square both sides just for neatness, bring that over here, and then I need the expansion. So we get cos squared B minus 2 cos A cos B plus the cosine squared of B plus sine squared T, A, sorry, sine squared. I've got some A's and B's missing. Here we go. Start back, here we go, sorry. Cosine squared of A plus the sine squared of B minus 2 sine A sine B plus the cosine squared of B. Now I want to look for some simplifications. I can take this cosine squared of B and this sine squared of B and use the Pythagorean identity. I can take this one and this one. So, using the Pythagorean identity, I get 2 minus 2 cos A cos B minus 2 sine A sine B. Next, I want to use the cosine rule. So I'm starting a new equation. So I should tell the reader I'm starting a new equation. So using the, from, this is built from the cosine rule. I can say that PQ squared is equal to 1 squared plus 1 squared minus 2 times 1 times 1 times the cosine. And I need the angle. So the angle on this one, notice that the angle A is here, and the angle I want is shorter than A. It's shorter than A by B. So A minus B is the angle I'm after inside my triangle. This is the right angle triangle I'm using. So this gives me A minus B. Simplifying that, I've got 2 minus 2 cos A minus B. Now at this point, I'm going to add my two equations together because the left-hand side of both is the same. But I need to tell the person that's reading it how I'm doing that. So I'm going to take this equation here and call it equation 1. I'll take this expression here and call this one equation 2. And then I'll say combining equations 2. So combine equation 1 and 2. So the left-hand sides are the same, so the right-hand side must also be the same. I can take away 2 from both sides, and I can divide through by minus 2. And this is going to give me the cosine of A minus B is equal to the cosine of A cosine of B plus the sine of A sine of B. And this is the compound angle identity for the difference of cosine angles. So there's 4 compound angle identities, basically sine, well, 6, sine and cosine and tangent, plus and minus a. They're all on the formula sheet. So just looking how this one appears on the formula sheet, we go to the Google Classroom. When you're working with the exercises today, I want you to use the formula booklet, because it's this that you'll use when you take your test, and you need to see what format they're written in. So if you scroll down to the trig equations, where are they? Here. So the one we're using is here. It's here. And you notice inside you've got a plus and minus, and you have a minus and a plus there, so you can see which one it is that you want.
Plus is plus and minus is minus for both of them?
No, look, just get used to using the formulas in the formula booklet here, seeing how they look. So you notice for sine, the plus is on top for both. Because it's all, if it's plus, then it's plus. If it's minus, it's minus. Whereas with cosine, it's the inverse. So if it's plus here, it's minus there, and if it's minus here, it's plus there. Yeah. Okay, have a go now at this. Do this as a simplifying the expression cosine of a plus b. Use the information here given to make the simplification. Let me just pause for a minute. So we're looking for another compound angle identity for cosine with the addition of 2 angles. Here in the hint, we can rewrite this like this. Then we can use the compound angle identity given. So let me just say, using identity given. This is equal to the cosine of A, cosine of minus B, plus the sine of A, and the sine minus B. If you don't know the name of a relation, like we're going to use the negative trigonometric relations. If you don't know their name, you can just quote them. I'm just going to use the cosine of minus theta is equal to the cosine of theta. And I'm going to use the sine of minus theta is equal to minus sine theta. You can get these from the unit circle, so you can just quote the unit circle. You can visually see them in the unit circle, or you can just quote the formula if you don't actually know it. That will work. So that's going to give us cosine A, cosine B, minus sine A, sine B. And there's a new trigonometric relation. Just to speed things up, I'm going to do this one for you. There's 3 more, we'll do this one. So we need to find a relationship for sine A minus B. And we can do it using the complementary angle identity. And that one gives us the cosine of pi over 2 minus A minus B. Sorry, Sarah. So to make this simplification, I'm going to shift the minus A across like this into that bracket. So then I have this over here. So I'll take the A out of the bracket, and it becomes negative, but move it across, put it in the first one. Now, using the compound angle identity,
Why did you do over 2 minus A and then you separated the minus B? Like, what is the reason why you did that?
because I need an identity, I can see it here. So let me show you. I can see here So we're starting with a compound angle identity, but we want to be ending with simple angle identities, geometric expressions. And if I use this as one of my angles, it's going to stay compound the whole time. So I'm doing this so I can hopefully get rid of compound angle identities. So putting it into the formula, I get the cosine of pi over 2 minus a, the cosine of negative, let me just check what I've got there, yeah, negative b, plus the sine of pi over 2 minus a, sine of negative b. So using the various relations now, I can use the complementary angle identity. I can use the negative angle identities. So using the complementary angle identity, this one becomes sine A. Using the negative identity, that one becomes cosine B. This one becomes, using the complementary angle identity, this one becomes cosine of A. And then using the negative angle identity, I get this here, and this becomes just sine. And here we have our third angle identity. You can do one for the cosine of the addition one, and just use the different ones to make the simplifications. And then there's 2 for a tangent as well.
We get cosine power to minus a cosine minus a plus that. So did we just expand cosine with cosine minus
No. So here at this point, I move across the A. And then, as I say here, I'm using the compound angle identity. So I've got 2 angles. I've got this angle here and this angle here. That's this angle there and this angle there, and then I use the right side to move them across. So here on this one, this simplification is the complementary angle identity. So here I'm using the cosine of pi over 2 minus a is equal to sine a. Over there, I'm using the other one, which is the sine of pi over 2 minus a equals cosine a. Complementary angle identities. All right, so let's have a go at this question. Use the, open up your formula booklet. Go to your formula booklet on the Google Classroom, find the compound angle identities. With that in front of you, open up this. And simplify. It doesn't take long. So we need to expand this using the angle identities first. So we check our formula sheet. Use this one here. We check our formula sheet, and we've got addition of sine. So we need sine 3 pi over 2, and it is cosine theta plus the, which way around is it written? It's written this way around. Cosine of 3 pi over 2 sine theta. So using the formula sheet, we get this expansion. Next up, we need to simplify. So I would simplify this type of values using the unit circle. 3 pi over 2 is this spot. This is 0 comma minus 1. The coordinate there. So the cosine value is 0 and the sine value is negative 1. So this gives us the sine value is negative 1. Cosine theta. Put the values in, so especially for a simplify or show that type question, you can see how you're making your simplification. And this gives us minus cosine theta.
Did you just say negative sine theta?
Minus cosine theta.
Yeah, but like I heard you say negative.
Maybe. No, usually I say the right thing and write the wrong thing.
I see it in the video. In the online.
Show that sine 75 is this. Okay, so do we know the exact value for sine 75? Let me hear it back.
We know like the exact value for sine 30 and sine 45.
Split it into 45 and 30. So do a left-hand side to right-hand side. Left-hand side is equal to sine 75 degrees, which equals sine 30 degrees. No, let me do 45. 45 plus 30 degrees. All right, expand and simplify using your rule. I'll give you a minute for this one. All right, so we can use the compound angle identity now for this one. And this is going to give us sine 45 cosine 30 plus sine, I think we do it as cosine 45, yeah, cosine 45 sine 30. Using the exact values, we get root 2 over 2 times, what's the cosine of 30?
Root 3 over 2.
So 3 over 2, and then root 2 over 2. What's the sine of 30? 1 over 2. Root 2 times root 3 is root 6. Root 2 times 1 is root 2. 2 times 2 is 4. And that equals the right answer.
We don't rationalize it at first, and then we rationalize it later. I thought we got it wrong still.
You don't have to rationalize it at first. You just have to rationalize it correctly. Let me do it for you. So here at this point, you could have written it as 1 over root 2 times root 3 over 2 plus 1 over root 2 times 1 over 2. This would give us root 3. Sorry, can I just have quiet while I finish this? That would give us this. We need to times top and bottom by root 2, and that would give us root 6 plus root 2 over 4.
2 times.
Okay. I ate, so let's go.
That is crazy. That is 10K work.